All right, so a couple students asked about rationalizing radicals, and I'm going to show you what and why we want to rationalize radicals. So rationalizing radicals, if you go back enough in time, prior to us having computing devices like calculators, it was difficult to conceive of specific numbers. So for instance, if I had this number, 1 divided by the square root of 2, that's actually 1 divided by 1.43. And if I don't have a calculator, what's 1 divided by 1.43? Not so easy, right? What if I could rewrite this to be square root 2 over 2? That, because I told you that square root 2 is equal to 1.43 approximately, then it's approximately 1.43 as well, because it's the same number, square root 2, but now I'm dividing it by 2. This is about 0.7, what is that, 0.715, blah, 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 right? Much easier to do the math in my head. If I had square root 2 over 2, square root 2 divided by 2, it's 1.43, blah, 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 divided by 2, about 0.7, 0.71, 0.72, right? 70%, 71%, however you want to think about it, okay? So there is an advantage to not having square roots in your denominator, because those irrational numbers are hard to divide with and hard to conceive of without a computing device. Yes, today I could just take negative 21 divided by square root of 7 and get some number. Yes, but that wasn't always the case, right? Imagine Egyptians walking around with stone tablets or wooden tablets and sandals in the desert or whatever, on the Nile, on the Euphrates, I don't know, whatever. So don't argue with me whether you need to know it or not. It's in here, you need to know it, okay? So that's not a point of discussion. Not angry about it, just saying I'm not going to bog it down with that. But we need to know how to do this. How do we do this? If you already know how to do this, just vacate, go, don't watch this, right? But I'm going to suggest that I need to multiply this square root 7 by something so that it's no longer the square root of 7. In fact, the easiest least value to multiply by to get rid of the square root of 7 will result in a 7. So the square root of 7 times what is equal to 7. And hopefully you thought about it and you said, yeah, square root of 7, because the square root of 7 times the square root of 7 is that, which is this, which is in fact that. So that should inform us that we want to multiply this times the square root of 7. That being the case, what do I do with this numerator? Right? What do I do up there? Well, this number that we're multiplying by cannot be anything other than the value of 1. It can be a representation of the value 1, but cannot be equivalent to any other value than 1. Why? If I multiply negative 21 over the square root of 7 by some other number besides 1, I will change its value. So this has to be a square root of 7 as well. This is now the number 1. It doesn't look like the number 1, but that version of the number 1 will allow me to change what that negative 21 over square root of 7 looks like. So negative 21 times the square root of 7, and then square root of 7 times the square root of 7 equals 7. That's my answer-ish. I can simplify that answer because negative 21 and 7 are both divisible by 7, or in other words, you can think of negative 21 divided by 7, and the final, most simplified version of the number is negative 3 divided by 7. Okay? So that's rationalizing the radical. Now, someone else had a second question, and that question was, hold on a second, was this question. So that was rationalizing radicals. Actually,